Welcome back. Today we will be seeing the problem from the LeetCode, that is to find all the numbers that are disappeared in an array. So let's first understand the problem. Suppose we are given an array and the length of this array is 4. Now we have to return all the numbers that are disappeared from the range 1 to n. So for this case, what will be our range? Our range will be 1 to 4, and that will include the numbers 1, 2, 3 and 4. And we have to return what are all the numbers that are missing from this array. Okay, so in this case, what are all the numbers missing? First we will check, is 1 present? Yes, 1 is present. Is 2 present? Yes, 2 is present. And is 3 present? Yes, 3 is also present. Then what is the only number that is not present? 4. So in this case, there is only one missing number, that is a 4. Now let's take another example. Suppose we have an array like this: 1, 2, 2, 2, 2. So what is the length of this array? The length of this array is 5. So what will be our number range? Our number range will be 1, 2, 3, 4 and 5. Now we have to return all the numbers that are missing in this range. So in this case, 1 is present, 2 is also present, and is 3 present? No, 3 is not present. Is 4 present? No. Is 5 present? No. So what will be our answer? Our answer will be 3, 4 and 5. Now let's talk about the approach that we will be using to solve this problem. Now let's analyze what are all the things that are given to us. We are given an array of length n, and the numbers that we want to check are in the range from 1 to n. So all the number will be positive. So here n is equal to 5. Now what we will do is we will maintain a data structure that will contain the numbers from 1 to 5. Let's say that data structure is a hash set. Okay, and we will be putting these all values in that set. So now let's forget about the code. How will you identify what are all the numbers missing? What you will be doing is you will see that, oh, 1 is present over here, it is present over here also, so this is not missing. So we will just strike through it, and exactly this thing we have to do. We have to eliminate all the elements that are present. Okay, now we have already eliminated the 1, then we will go towards the 2. Okay, 2 is also present. We will remove this, and now we encounter another 2. But when you try to remove this 2, you did not find any 2 over here. So basically you will be deleting nothing. Now you will go to another 2, and you will go to another 2, and these 2 will not be removed at all. So in this case, what are all the numbers that are remaining in this set? 3, 4 and 5. And yes, this is our answer, 3, 4 and 5. Now the question arises, why are we using the hash set? We are using hash set because it takes big O of 1 time to delete an element from it. Basically it takes constant amount of time. So what is the time complexity of this algorithm? Let's see. We are only traversing the array once. So the time complexity of this algorithm will be big O of n. Now, is this the most efficient way to solve this problem? Actually, no. What if the Interviewer asks you a question that you don't have to use this extra data structure that is needed. Then at that moment, this will be a very tricky problem and this will use a really nasty trick over here. So let's analyze the problem one more time. We are basically given numbers in the range 1 to n. In this case, we are given numbers in the range 1 to 5. So, as the range starts from 1, we could say one more thing, that all the numbers in the range are positive. So, can we use this to our advantage? Let's see. Now, let's try to analyze the input. Okay. Now, what if we try to map this one to its correct position? Now, the first question that comes to mind is, what is the correct position of 1? Okay, now let's try to see the range again. The range is from 1 to 5. And what will be the indexing of our array? It will be from 0 to 4. That means if we subtract 1 from the first number, that is 1 here, it will give us a 0, 2 will give us a 1, and similarly 5 will give us a 4. So that means this 1 belongs to position 0. Now let's map the position 0 as visited. So how will we mark this position as visited? Basically, we can mark this position as visited by changing the element at that position as negative. Okay, so now let's try to use this algorithm here. We went to 1 and we asked him, what is your position? He says, my position is 0. Now what we will do is, whatever the number present at the 0th position, we will make that as negative. In this case, it is -1. Now let's go to the next element. Now 2 says his position is 1. We will mark the number at the position 1 as negative. So this will be a -2. Similarly, we will do for this also. But you see, his position is also 1 and 1 is already visited. So in that case, we don't have to do anything. Let's move forward. His position is also 1 and this position is also 1. So in this case, our resultant array will look like this. Now observe one thing, that we are not using any kind of extra space over here. We are actually modifying the array that is given to us. So now let's loop through this array one more time to find our answer. Basically, we encounter the 0th position. Okay, the element at this position is negative. So that means this is visited. First position is also visited. And now the second position, this is not visited. So in this case, what is the index? The index is 2. And what if we add 1 to it? We will be getting the number that is missing. Hopefully this makes sense to you all, guys. What is the position of this one? The position is 3 and 3 plus 1 is 4, and the position of this one is 4 and 4 plus 1 is 5. And these are all the numbers that are missing from our array. Now let's quickly code this up. Okay, so first of all, we have to return our answer in the list of integers. So let's quickly make that list integer res. This will be new array list. And now let's try to mark the numbers. Okay, now for that we will traverse the array I is equal to 0 from nums dot length and I plus plus. Okay, Now let's get the element at the current position. And what will be that? Int n, that will be equal to nums of I. But what if this position is already visited? That time we will be getting a negative one, and we don't have negative indexing in our array. So what we will be doing is we will be making this number as absolute. Okay. Now, but still we have one more thing to do. We also have to subtract 1 from it, because the numbers are from 1 to n and our indexing starts from 0 to n minus 1. Therefore, we are subtracting 1 from it. Now, let's mark it as negative. And how will we do that? We will be doing this. And what we will do is we will be multiplying minus 1 and then the absolute portion of this. And why we did this? Because if it is already visited and if we multiply minus 1 to that, it will be positive and that will be incorrect. So we have to take the absolute and then multiply with the negative one. So we guarantee that this number is always negative. Now let's quickly traverse through the array and see what are all the positions that are visited. 0, and this will be to nums dot length and I plus plus. Now, if the position is visited, that means it is a negative. And if the position is not visited, that time we know that the number that belongs to that position is not present in that array. So what we will be checking is if nums of I is greater than 0, that means if this position is not visited, then that number that belongs to this position is absent. So we will just add this. And how will we do that? We will just increment 1 to the current position and we will be getting that number. And this is the entire solution for this problem. And in the end, we will just return the result. Now let's quickly check our answer. And it is correct. Now let's submit that. And as you can see, the solution is quite efficient. And this is all for today. I hope you find this video helpful and you have picked a thing or two from this. And if you really find this helpful, please give it a like and hopefully I'll see you in the next one.